So let's look at another example in spherical coordinates. So let's find the volume of the solid region Q bounded below by the upper nape of the cone z squared equals x squared plus y squared, and above by the sphere x squared plus y squared plus z squared equals 9. So again, maybe we want to start by taking our two equations and graphing them. So I've taken the liberty of doing that for us. So let me move this up a little bit. So remember, a cone is made up of a top portion and a bottom portion. We're only looking at the upper portion, so this one here. So you want the part that's bounded below by that and above by the sphere. So you're talking about essentially this region in here. All right, so, or that's solid. So now I'm going to take my equations and I want to convert them into spherical. So the easiest equation to convert first is the sphere equation. Well, I plug in rho squared in place of x squared plus y squared plus z squared. Rho squared is 9, and if you solve for rho, you get rho equals 3. And so before we do too much on converting, here let's find the intersection of the sphere and the cone. So the question is, where do the sphere and the cone intersect? Well, let's look at our two equations, right? X squared plus y squared plus z squared equals 9. And in our other equation, we had z squared was x squared plus y squared. So what I'm going to do is I'm going to plug this in place into my sphere equation. So for x squared plus y squared, you can plug in, that is z squared. So you get 2z squared equals 9, which means z squared equals 9 halves. And z is only positive here because we're looking above the xy plane. So z, if we solve for z here, it'll be 3 over the square root of 2. Well, that doesn't really help us a whole lot. I mean, we're not quite done is what I'm trying to say, because we need our information in spherical coordinates. So let's see, what does z correspond to? Z corresponds to rho cosine of phi. So I know, so if I solve for cosine phi, I get z over rho. So cosine of phi will be, rho is 3, and z we just found to be 3 over the square root of 2. So cosine of phi is 1 over the square root of 2, or in other words, square root of 2 over 2. Remember that phi is an angle between 0 and pi. So what angle between 0 and pi gives you square root of 2 over 2? For cosine, it's pi over 4. So that gives us our bound on phi. And then theta, if you look at our picture, theta will go all the way around from 0 to 2 pi. So what we're going to do, rho goes from 0 to 3. phi goes from 0 to pi over 4, and theta goes from 0 to 2 pi. So we're going to use the order in our integral d rho, d phi, d theta. And so now we can set up our volume here. Volume 0 to 2 pi, 0 to pi over 4, 0 to 3. And when you're finding volume, you're integrating the function 1. But because we're doing spherical coordinates, we're going to have a rho squared sine phi, d rho, d phi, d theta. So then the volume, integrate first with respect to rho, rho cubed over 3. So then you're going to get 9 for that, which I'll go ahead and do. So you'll get 9 sine phi, d phi, d theta. So integrate 9 sine theta, or sine phi. You'll get minus 9 cosine phi. So then this amounts to the integral from 0 to 2 pi minus 9 cosine pi over 4 minus a negative, so it becomes positive 9 cosine of 0. So this becomes negative 9 square root of 2 over 2 plus 9. So then we're going to get minus 9 square root of 2 over 2 plus 9. You integrate, you get theta from 0 to 2 pi. So you're going to get 2 pi times that. And there's my answer.